Hello guys, welcome back to today's video. In our previous videos, we've been learning how to model this structure where we've been able to place our beams, our columns, our slab. And in our last video, what we did was to model our staircase that we did perfectly. So in today's video, I'm going to do something quite different. I gave a brief description of what this video is going to be about in my previous video, and I said we are going to learn how to mesh a slab. We are going to mesh this slab. One might ask, what does that mean? Like when I say I'm going to mesh a slab, is it really important to do, or can I just omit it? Like what are the advantages, and what happens if we don't mesh the slab? We are just going to talk about all this in today's video. So just pay rapt attention and you're going to enjoy this video. And also don't forget to like this video and all the subsequent videos I've made. And also subscribe to the channel, as it really helps us to know that you are really engaging with the content we are creating. So don't forget to do that. And also don't forget to also leave a comment in the comment section. Anything you just want to know about, any video you want me to just leave a comment section and I'll just make sure to get back to you. So let's get into today's video. So first of all, I have to open my Etabs app that we all know. So we are talking about meshing a slab. Why do we mesh a slab? Meshing a slab is like you are dividing the slab into smaller pieces. We all know that Etabs is a finite element method like software. Like it uses finite element method to analyze structures by just dividing the member into various divisions, so smaller or larger. Because with these divisions, the Etabs software is going to run the analysis by these divisions. So you can either choose to divide your slab into smaller sections or larger sections, because it's going to analyze each individual section that you've created. There are advantages and disadvantages of making them smaller and also making them bigger. So when you want a very good accuracy, you try to make the divisions quite smaller, but you also have to put in mind that when it becomes too small, the analysis of the various sections become too many for the software. So like when it's designing the slab or doing the analysis, running the analysis, everything becomes slow, it takes time. And we also make sure not to divide them into bigger sections, because it creates like inaccuracies. So this is what we have to take note. I know right now you might not be really understanding what I'm talking about, but at the end of today's video, you are going to get it and you're also going to enjoy. So first of all, is the slab I'm going to mesh. So I'll have to select each and every slab, because I'm going to assign a mesh to that slab. So you know that before we assign a command to a member, we have to select it. So you can go through by selecting each slab one by one, but it's going to take a lot of time. And I don't want to just waste much time in selecting of these slabs. So with a much faster approach, we can just go to select property slab sections, and my 180 mm I'm going to select, and everything is just going to select, including the staircase. So we are done selecting this, and now we are just going to assign the mesh to this slab. So the staircase is also a slab, so we are just going to assign a mesh. The mesh is not really a structure like elements that you are saying, say, I'm placing a rebar into this slab, I'm placing no reinforcement into this slab. It's not a structural element. It just makes the slab behave more in a realistic manner. As in, when it comes to the distribution of loads, the loads are distributed with some form of accuracy into the various supports, either it's the beam or the column. The distribution within the slab is very accurate. But when you don't mesh your slab, it's unable for the Etabs app to analyze this. Looking at this, our slab has already been meshed, but it's a default. The AutoCAD, the Etabs has its own default mesh, but I don't really like to use the default mesh because when you are using the default mesh in the form of analyzing slabs that are of like irregular shapes, it causes some form of inaccuracies. So you should make sure that you should assign your own mesh to the slab. So I'm going to show you that Etabs already has its default mesh. So I'm just going to just right click on this slab, and look here, we have floor meshing options. It's default, it's not none. If it's supposed to be none, that means this slab has not been meshed, but it's our default. That means the Etabs app has its own default meshing properties that it gives the slab, but we don't want to use these defaults. We want to use our own mesh that we create. So we just have to just click on OK, then we go to assign. It's, you know that our slab is not a frame, it's a shell, like it's a shell object. So we'll shell, then we come to floor auto mesh. It's a floor, so auto mesh, so floor auto mesh, then just click on this. So this is what appears here. So this is the default that the Etabs app uses to mesh the slab. So you can decide to stick to this default, but I will not really advise for that. So I'm just going to check this box. That's a mesh object into. So this one, you are just going to like divide the slab into various sections, maybe 2 by 2 or maybe 1 by 1. It really like depends on you. So I'm going to go for like 2 by 2, just like this. Or I can also decide to choose this auto kiki cut object into structural elements. With this one, you are just going to select the various like the ways you want the mesh to be. So with this one, we have mesh at beams and other meshing lines. So you are going to like, it's just going to, you are giving them like some rules the meshing is supposed to follow. Mesh at vertical or inclined wall edge. So you can just choose to either use this, but I really don't like the option. So I'm just going to mesh objects into 2 by 2. And also I'm going to check this box because I want to add restraint on edges if corners have restraints. So that's it. So once I'm done with this, with my slab and everything selected, I'm going to apply this. And okay, so now our mesh has been applied. We've assigned our mesh to this slab. So now our slab is now able to just distribute or act realistically in terms of the distribution of the loads and all those things. So our mesh is now 2 by 2. So shell analysis mesh and okay, so this is it. Looking at our slab here, you can see these lines through them. These are the mesh in the slab. But for this, you can see maybe your mesh is too big, you want to maybe reduce it, so you can just go to previous select. So these are the mesh. You see these lines, these are the lines cutting through, but you should also make sure that these lines are continuous throughout. This line can't be here and we have another line disconnected over here. It has to be continuous throughout. We are not supposed to divide our slab into very smaller sections. Also, it shouldn't really be in larger sections. So our 2 by 2 that we used, we could see that the division was very large, and when it's so large, the analysis is there's some form of like inaccuracies in the analysis. So let me show you how large they were. So shell to floor mesh, so 2 by 2. So this is how it's going to look like. So just looking at this, every panel, the division is very large because this is like 6 meters and the division is like 3 meters, 3 meters. So 3, 3, and it's very large. We don't really want it to be that way. We want them to be a bit small, but not too small. So let's say like we take like 6 meters. 6 meters, you want so you just have to divide our slab length, the span of the slab, by, let's say, either 10 or 20. It's up to you. Like you can decide how you want to divide your slab into like various meshes. So you can say that you want it to be like 4 by 4. So I'm just going to select previous section, and it's going to select the slab. So select property type. So it's selected now. So let's try 4 by 4 and apply. So just looking at it, we can see that now we have some divisions in the slab, which is not too big but not too small either. So it has to be like in that kind of range. So yeah, it doesn't have to be too big and too small. So with this, our slab has been meshed, and now it's going to really behave as if it's a realistic one, because it has to be realistic for the analysis to be also accurate. So one might ask, like, what happens if we don't mesh the slab? When we don't mesh the slab, as I've been saying throughout the video, it creates some form of inaccuracies in the results. So without meshing, the analysis might, just yield like inaccurate results, as the software cannot perform the necessary calculations on an unmeshed model. So you have to mesh your slab, and not just mesh it in any way. I just showed like it should. And also, like, when you don't mesh the slab, it can lead to like failure to run analysis. So Etabs may not allow the analysis to just proceed without a defined mesh. The software requires a discretized model to perform calculations. So even when we started the video, the Etabs already had a default mesh that it already applied to the slab. So this is to let you know that any slab you're creating, when you're about to run your analysis, you have to mesh it. If you don't mesh it, you can run into like errors or like, yeah. But if you don't run into errors and you don't really mesh, it doesn't really mean there's no mesh. There's a default one there. That's why sometimes when you just run your analysis without mesh, you don't really encounter any errors. So this is about meshing. So now we are done with meshing our slabs. So now we have our slab meshed, and these are the various sections here. And one thing I want you guys to just take into consideration is that I'm not saying like it shouldn't be that small. Actually, when it's very small, that it really gives accurate and results in the analysis. But it depends on maybe your machine or how fast you want your analysis to go, because when you divide them into very smaller like partitions, the analysis is going to take very long, because it's going to analyze these smaller sections one by one. Just even though it's a machine and it really does that quite fast, but still dividing them or meshing them into smaller partitions is going to make the analysis very plenty for the software to do, which it will do, but not really the best scenario like here. So that's it for today's video, and in our next video we will be assigning loads to our structure. That's our dead load, live load, wind load, and also we are going to consider seismic load. Yes, that's also very important, because we are going to just replicate this building. It's going to be like a very tall building, so we really have to just consider our seismic load soon. So that's it for today's video. Don't forget to like today's video and also the subsequent ones, and also subscribe to my channel, and don't forget to leave a comment in the comment section. If there's anything you just want to know about, just comment. Thank you.